Hello, algebra students. Today we're going to come back and review some of the recent topics that we have gone over in here, which would be slope, getting slope-intercept form, or y equals mx plus b, and going all the way back to graphing lines using x and y intercepts. So the examples that I have today in this video are right from your worksheet. So you should have your worksheet out right now. You should do these couple of examples along with the video, so you've got these to look back at when you're working later. Remember, for slope, we have a slope formula. However, number one, I don't really even need a slope formula. Number two, we don't either because we're graphing or we're looking at the graph. In number one, this is a vertical line. If you think about Mr. Slope Guy, you should know right now what this slope is going to be. But to remind you, slope, use the letter F, and we use rise over run to count our slope. So this graph, if I would start, let's say at the bottom, because I can't start at the left because there isn't a left or a right. If I start right here and I move up 2 spots, I'm going to go up 2, but I'm going to go sideways 0. And that 0 in the denominator is the issue. You cannot have this. This makes us unhappy. So this is going to be an undefined slope. That's an undefined fraction, it's called. It's an undefined slope if the 0 is in the denominator of the slope fraction. Number 2 is not going to be undefined or 0. It's not one of our special ones that we have to worry about. It's just a regular slope. However, it is going downhill. So don't forget that when we're going downhill, this is going to have to be a negative slope. I have said this before, but I would really, truly recommend that you always go from left to right when you're counting your slopes. So to go from the point that's on the left, I'm going to move down 1, 2, 3, 4. So down 4 would be a negative 4, and then sideways 1, 2, 3, 4, 5, 6, 7. Now, that doesn't simplify. If we can simplify fractions for slope, we need to. We can leave improper fractions. This one's not improper, but that can happen sometimes. But 4/7, there's just nothing that I can do there to kind of clean that one up. That one's just done. Now, instead of having a graph, and I truly wouldn't want you to try to find graph paper and graph these and then count. And look, both of these examples have points that would be pretty difficult to get on the smaller size graphs that we usually give you. So let's remember the slope formula. Remember, it's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we have these two examples. I'm going to do this one by labeling. Here's an x, here's a y. Here's an x, here's a y. I've also mentioned that I don't always do these in exactly the same way. Sometimes students always want the first order pair to be the 1s and always want the second order pairs to be the 2s. Sometimes they want to flip it around and have the first order pairs the 2s every single time. I tend to go with whichever method or whichever order would make the most sense here. But I'll do this problem 2 different ways. The way that I would choose to do this is I would make these my 2s and these my 1s. And when I do that, I would have 18 minus 2 over 20 minus 2, just putting my numbers in the right spot, which would give me 16 over 18, which gives me 8 over 9. If I said, you know, I want these to be my 1s and these to be my 2s, which is what, again, a lot of students prefer, then I would have the way that I have it labeled now, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now I would probably want to do a keep change on both of these, and I get negative 16 over negative 18. And we know that if they're both the same signs, it's going to be a positive answer, and I could simplify this down to 8/9. So I don't care which pair is the 1s and which pair is the 2s. It'll work either way. In number 8, instead of labeling everything, I'm going to do my kind of shortcut method where I just draw my lines. The y's get connected on the top because the y's go on the top. The x's get connected on the bottom because the x's go on the bottom. So I'm going to go with, again, probably the way that most of you would want to do this is 12 minus 6 over negative 17 minus 7. Notice I started with the 12 right here and went to the 6. So then I'd have to start with this negative 17 and go to the 7. I would have to do a keep change on the bottom, not on the top. I would have 6 over negative 24. This can simplify though. I know this fraction is going to be negative, so I don't need to leave the negative in the denominator. It can just be out in front of the entire fraction. And 6 over 24 would be 1/4. The next section of the worksheet is getting slope-intercept form. Getting the y by itself, y equals mx plus b. So, on number 15, remember my goal is to get the y by itself. So don't just start randomly moving things back and forth. Think about your plan here. The 2 is attached to the y. That's the last thing that's going to go away. So let's add 10 to both sides. So I'll have negative 4x plus 10 equals 2y. But I don't want 2y. I just want y. So I would want to divide, divide, divide. So I get negative 2x plus 5 equals y. And then, we want to put that y first. In number 16, again, trying to get the y by itself, I really want to get rid of that 7x. So when I add 7x to get rid of the negative, or subtracting 7x, it'll move to the other side. And again, don't fall into the trap. 4 plus 7x is not 11x. The 4 doesn't have an x with it. And I want it to look like slope-intercept form. So 4 plus 7x isn't wrong. But 7x plus 4 looks more like slope-intercept form right now. And again, I also don't want 2y, I just want y. So we're going to divide, divide, divide. And we're not going to freak out about fractions because that's 7 over 2, that's the slope. We know that we get fractions for slope all the time. And we'll have a plus 2 at the end. In 21 and in 23, you can see these aren't 21 and 22. I wanted one of each kind of problem here. We are graphing these, but I want you to use x and y intercepts, especially on 21 and 22. So for this problem, I would want to start with my tiny little table of values. So if the y is equal to 0, I'd be putting the 0 right here. Well, subtracting 0 doesn't do anything, so I could really just ignore this whole part of my equation right now. My equation is just 2x equals negative 4. Now you could show that work, or you could just do, divide both sides by 2 in your head. You're going to get that x is negative 2 because 2 times a negative 2 is negative 4. So negative 2, 0, it's going to be right there. That's my x-intercept. To find the y-intercept, I'm going to say that the x is equal to 0. And I have mentioned this before as well. I'm concerned that people kind of cover up or scribble out too much of this equation. If the x is 0, 2 times 0, you know that that's 0. But what some people want to do is say, oh, well, then adding and subtracting 0 doesn't matter. So they try to scribble out all of that, and they lose that negative or subtraction that's with the y. What I really need to do is I need to think about that like negative 1y. And now I can say, oh yeah, I don't even need that. So negative 1 times what gives me a negative 4? Well, it's a positive 4. So right there's my point. And then we'd be able to graph our line with the 2 points. 23 and 24 are different because there's only one variable. In 23, there is no x. It's only a y. If there's no x, it will not touch the x-axis. That means it's going to be horizontal, so it's parallel to the x-axis. So if y equals 2, there is my equation. Never going to touch the x-axis because, again, I don't have an x in my equation. Y is equal to 2 at every single point that I have graphed on that line. So today's worksheet is the rest of the worksheet that you were just working on. Review slope, get y equals mx plus b, graphing with intercepts. There is an answer key in Schoology. Let me know if you need any help.